Hello, everybody. I'm Vishal, a PhD student at the University of Cambridge and Tübingen. I'm excited to present our ICCV paper titled SuS-X, Training-Free Name-Only Adaptation of Vision Language Models. This is a joint work with Ankush and Sam. CLIP is ubiquitous in the vision language community these days. However, it does suffer from one key issue. The issue being that when the downstream task we test CLIP on diverges too much from the pre-training dataset it has seen, the downstream performance of CLIP tanks. To this, we propose a simple solution called SuS-X that consists of two main components called SuS, support sets, and TIP-X, training pre-adapters. Our main goal is to adapt CLIP without seeing any downstream task data and without using any gradient updates, so without training. Our two proposed methods solve each of these independently, and we combine them complementarily later on. For the first problem, we have no images from the target distribution. What this means is we essentially only have the class names of the target task at hand, and we need to do something with these to improve downstream performance. One easy fix to using these class names, which we propose to call name-only transfer, is to leverage advances in generative modeling and vision databases to generate or retrieve images similar to the target distribution. So we can essentially mimic the true target distribution. We simply take the class names and generate or retrieve using Stable Diffusion or 11.5e class-specific target dataset images. And we can then essentially get training data for free without having true target task data samples. The next challenge we face is coming up with a training-free adaptation method. Here we show zero-shot CLIPS pipeline. It essentially takes a test image and computes the image-to-text similarities between the test image and a bunch of target class prompts. If we did have some labeled images, a previous method called tip adapter computes the image-to-image similarities between the test image and the few shot labeled images. From this, they get nearest neighbor logits, which are augmented with the zero-shot CLIP logits to enhance performance. However, we uncover a key issue in this methodology, the issue being that they essentially use the image-to-image similarity for computing these nearest neighbor logits. However, because of the well-known modality gap in CLIP, using image-to-image similarities can be miscalibrated. We find that this is connected to the pre-training strategy that CLIP uses. During training, CLIP optimizes intermodal similarity alignment. But because of this, the intramodal similarities between image-to-image and text-to-text are squished and miscalibrated. Therefore, at inference, using these can be miscalibrated and bring harm for evaluation. To fix this, we propose a simple augmentation on top of tip adapter. Instead of using intramodal distances or similarities, we simply make use of intermodal similarities as a bridge. We compute, similarly to tip adapter, the similarities between the test image and all the class text prompts and the support set and all the class text prompts, and then use both these matrices to compute the KL divergence as a similarity metric. Using this method, we now have a strong training-free method that can work well with a few short images. We simply combine both of them and show that this brings complementary benefits downstream. We show state-of-the-art results on 19 datasets and outperform all zero-shot and name-only transfer methods in the literature. We also have strong generalization performance for our method and bring gains even in the few-shot labeled regime. For more details, and if you're interested, I'm happy to chat more during the poster session, and please feel free to look at our webpage or GitHub. Thank you.